Students, today we are going to perform our first experiment, that is a Argentometric titration, and the aim of the experiment is to determine the chloride content in a given water sample by Argentometric titration. So what we are going to look here, that is chloride content. Basically, if you look into the water it contains hardness in it, and the hardness is because of the presence of calcium and magnesium ions. When the calcium and magnesium ions, they are associated with different kinds of ions like chlorides, sulfates, carbonates, bicarbonates. Depending upon that, we can divide this hardness into two categories, that is temporary hardness and permanent hardness. The temporary hardness, when calcium and magnesium ions, they are associated with carbonates and bicarbonates, and permanent hardness when it is associated with chlorides and sulfates. So now you can see that the aim says that we have to determine chloride content. That means somewhere it is related with the permanent hardness. And also at this point, I would like to tell that temporary hardness is easy to remove. Just by boiling of the water, we can remove. But the permanent hardness cannot be removed by boiling of the water. And we need to perform some kind of cumbersome processes over there. And also, if a permanent hardness is not present in the permissible limit, then it creates lot of problem. That water cannot be directly used for drinking purposes. It cannot be used for irrigation purposes. It cannot be used for the various industrial processes, not even boilers, etc. The permissible limit of the chloride content depends upon the ppm. That is like if it is present up till 150 ppm, it is very good water. If it is lying between 150 to 250, it is good. Up till 300 ppm, we can accept that chloride content. But beyond that, if it is present, then the water is not suitable for drinking purposes. That is why we need to determine the chloride content present in the water sample. The experiment, it is also known as Argentometric titration because we are going to use some silver compounds with some silver reagents for determination of the chloride content. And the general name is which is given for this experiment is precipitation titration. Reason behind the formation of the precipitates which are going to take place. Before the endpoint and after endpoint, there is a formation of precipitates which are there. Generally, these precipitation titrations, they are of three categories, that is Fajan's, Vollard and Mohr's method. And out of these three, you are going to perform Mohr's method, which is an indirect estimation or indirect usage of this silver compounds. The reagents which you are going to use today, they are silver nitrate solution, standard sodium chloride solution, and internal indicator, that is potassium chromate, which is yellow in color. Now let us see that what is the theory, on which theory it is based, the principle of the experiment is based. Basically, the principle of the precipitation titration, it involves the identification of the endpoint of the titration through the change in the color of solution due to the formation of a new precipitate. So as now I have told that the two precipitates which are going to form, one is before the endpoint and another at the endpoint. At the endpoint, the precipitate which is formed is having a different coloration, and due to that you are able to see the change in the color, and you will be able to perceive the endpoint of the titration. In general, what we do in Argentometric titration, we are going to take the chloride ion which are present in the water sample, and we will titrate it against the standard silver nitrate solution in the presence of indicator, that is potassium chromate. So as the titration proceeds, the chloride ions which are present in the sample water, they are going to react with silver nitrate, and it forms a precipitate of silver chloride. From the reactions also you can see that the water which is containing chloride ions. They are going to react with silver nitrate. They will lead into the formation of silver chloride and leading into the formation of white precipitate. So this is the first precipitate which has formed. Now, if you look back, the silver chloride, once it is formed, when all the chloride ions which are removed in the form of silver chloride, then when one extra drop of silver nitrate is added, it is going to react with the indicator to form silver chromate. So in the next reaction, you can see that silver nitrate, when an extra drop, when all the chloride ions, they are attached with the silver, afterwards a single extra drop of silver nitrate which has been added is going to react with the indicator, that is potassium chromate, will lead into the formation of silver chromate precipitate, which is reddish brown in color. So what is happening? You can see that once we have added this extra drop of silver nitrate, it reacts with the indicator and the silver chromate precipitate has been formed. So the formation of this reddish brown precipitate marks the end point of the titration, and at the end point the solubility product of silver chromate exceeds that of silver chloride. Because of that only, it favors the formation of silver chromate over AgCl. So always remember the basic principle of the precipitation. There is a relationship between the solubility product and the ionic product. As the solubility product exceeds, and that is why this has been precipitated out. So that is why the formation of the silver chromate has taken place and it has been precipitated out. So the two reactions which are involved, you can see that at the first moment you have seen the formation of the silver chloride, and at the end point the reddish brown precipitate of silver chromate which has been formed. The end point is marked by the formation of this reddish brown precipitate of silver chromate. You can see the color before the end point when you have added silver chromate to the NaCl solution or to the water sample. You are going to observe this yellowish color. At the end point, the color which has changed is a reddish brown color because of the formation of silver chromate. And if you are going to add extra drops of, or you can say beyond the end point, you are going to get this brick red color. So at the end point, we know that we need to see a light color which should persist for the longer time. Now always remember these argentometric titration, they should be conducted between the pH of 7 to 8, because if H plus ion concentration is more, then the chromate ions, they are going to react with hydrogen ions. These H plus ions will ultimately forms dichromate ions. Whereas if the OH ions, if they are more, then the silver is going to react with hydroxide, leads into the formation of silver hydroxide, and ultimately it will form silver oxide, which shows the black precipitate. So that means the pH, it should be between the 7 to 8, so that such kind of reactions, either the formation of bichromates or the formation of silver oxide, should not take place. Suppose if we are finding the black precipitate itself, instead of getting this white precipitate, if we are getting this black precipitate, it will indicate that hydroxides are in excess over there. And if the base is more, we need to add few drops of acid. If acid part is more, then we need to add pinch of calcium carbonate so that we can maintain the pH between 7 to 8. Now let us see the procedure part. The procedure, according to the procedure, the first thing is always to prepare a standard solution. And here in this experiment, we need to prepare a NaCl standard solution. For preparation of this standard solution, you will be provided with 0.24 grams of pure sodium chloride crystals, and you need to dissolve it into 100 ml of standard flask. You have to dissolve the crystals in the minimum quantity of the water, and the water which you are using for dissolving should be a distilled water. Make the solution up to the mark which is given in the standard flask. Shake it well so that the even concentration is there. And afterwards we can calculate the normality of NaCl. So you can see we can calculate the normality, and the weight is already given to you. The weight is 0.024. Put that weight multiplied by 10 divided by the equivalent weight of NaCl, that is 58.5. You are going to get the normality of NaCl. Next part, that is standardization of silver nitrate. Now in the burette, we are going to fill our burette with the silver nitrate, and in the standard and the conical flask, we are going to pipette out 10 ml of this standard solution, that is NaCl. Now in this NaCl, you have to add 2 to 3 drops of potassium chromate indicator. As soon as you will add this potassium chromate, you are going to observe this yellow coloration. The flask A, which is over there, shows this yellow coloration. This is NaCl, where we have added 2 to 3 drops of potassium chromate, shows the yellow coloration. Now you start proceeding with the titration. Start the addition of silver nitrate. As soon as you will add silver nitrate, suddenly formation of silver chloride will take place. So we know that silver chloride is white in color. You are not going to get a very sturdy white color, but yes, your solution will slightly turn into whitish yellowish color, and that indicates that the formation of this AgCl is taking place. Once all the chloride ions are attached with silver and 1 extra drop of silver nitrate will be added to the analyte, you are going to see the formation of this pale yellow solution converting into pale reddish brown. So the pale reddish brown, as soon as it appears, you have to stop the addition of silver nitrate, and you should wait that this color should not go away or should persist in the flask, and once it is there, you have to note down the reading. So you can see that you have got this pale reddish color, and this pale reddish brown color is because of the formation of silver chromate. Now you need to repeat the process for another 2 times and try to take a concordant reading. Always remember that the first reading is the reading which is giving you fair idea that where we are going to get the endpoint. Another 2 readings or the next reading is always lesser than the previous one. So if you are good in the titration, you are going to get the concordant value. If your hands are not set with the titration, then instead of getting concordant reading, you may get 3 different readings. So let us assume that the volume at the end point, whatever the volume or the values are there, they are the volume of silver nitrate which is consumed. So in the observation table, you are going to write the initial reading, write down the final reading where you have observed the reddish brown color. Subtract the value, you will get the volume of silver nitrate. Like so, you have repeated for 3 times. You have done this experiment for 3 times. You need to take, if you are having a concordant value, that concordant value can be taken as V1. If it is not concordant, हम जो है इसका we can take the average of these 3. So that will give you V1 volume. Now coming to the next part, that is blank titration. Now the blank titration is a titration where we will repeat the same process, but instead of taking that standard NaCl solution, we are going to use the distilled water in which we have prepared our NaCl solution. So remember that the distilled water, chances are very less that it is containing some chloride ions, but then also it may contain some chloride ions. So that means when we have used this NaCl, the 2 types of chloride ions were there. One which were actually attached with the sodium ions, another the distilled water which may contain. So due to that, we are going to perform this blank titration so that we can come to know whether the distilled water was containing any chloride ions. If it was containing chloride ions, it has also consumed some silver nitrate. So now what you are going to do, you are going to pipette out 10 ml of distilled water. In that 10 ml of distilled water, you will add 2 to 3 drops of potassium chromate indicator. Again, your solution will turn into yellowish color. Start the titration, and once your solution turns into reddish brown color, stop the titration and note down the reading. See students, you have to be very careful while you are performing this, because the distilled water will contain very less amount of chloride ions. So maybe within 1, maybe within 1.5 you may get the reading. So now the actual volume, we need to see that what is the actual volume of silver nitrate consumed. So what we will do, V1 minus V2, this value which we have got through the blank titration is actually V2. So the V1 minus V2 will give us the actual volume of silver nitrate which is consumed. So in the observation table for the blank titration, the initial reading will you have to write, and the final reading which you have obtained over there. Subtract the value, final में से initial minus कर दीजिए, you are going to get the volume of silver nitrate, and put this value as V2. Now further you do the calculation, calculate the normality of silver nitrate. So normality of sodium chloride, which you have already earlier calculated before, multiplied by the volume of NaCl. Volume of NaCl which you have used is 10, put that value, divided by the volume of silver nitrate, that is V1 minus V2. So, feed the formula, do the calculations, you are going to get the normality of silver nitrate. Moving ahead, coming to the part C, you have to determine the chloride ion in the given sample water. So you will be given a sample water. You have to pipette out that sample water 10 ml and release it into the clean conical flask. Afterwards, in that water, you are going to add 3 to 4 drops of freshly prepared potassium chromate indicator. So now again, the freshly, whatever you were actually using, that was a freshly prepared only. So add 3 to 4 drops of this potassium chromate. Again, the water will change its color to yellow. Start the titration. Do the standardization till you are going to obtain reddish brown or pale brown color. The moment solution converted into pale brown color, it indicates that formation of silver chromate is there. And you have to repeat for another 2 times. That means total 3 readings you have to take. So this is the volume 3 which you have obtained from the part C. Now the observation and calculation part, in the observation table you can write the initial reading, then the final reading, subtract the value, final minus initial, you are going to get the volume of AgNO3 in the ml, as you have repeated the process for another 2 times, so you are having 3 readings. Similarly, if you are having a concordant value, take the concordant value. Otherwise, if all the 3 are different, you can take average. In general, what is there, you are supposed to take the concordant reading, because sometimes it happens if you are taking a average of these 3 readings, the readings which are obtaining maybe 10.32. So you cannot read this 0.32 in the burette, because only the after decimal there is a 1 place is there in the burette and you cannot read that. So always remember that taking the average of the reading is not a right practice. The right practice is that you should get a concordant value, and you have to master in that. When you are able to perform the titrations, students then only they learn how to go for the titration, and how, if they are doing precisely, they are going to get the concordant value. So once you are having this volume 3, you need to calculate the normality of the sample water. So normality of silver nitrate, which you have already calculated before, multiplied by the volume which you have got through the titration, that is V3 ml, and divided by the volume of sample water, that is 10 ml. Feed all the values in the formula, calculate the normality of the sample water. So once it is done, afterwards you need to calculate the strength of chloride ions. So the strength of the sample water which you have calculated before should be substituted in the formula, and multiplied by 35.5. 35.5 is for the chloride ions, you know it very well. Multiplied by it, you are going to get the value in terms of grams per liter. And when you will multiply this value by 1000 ppm, you are going to get the value in terms of ppm. So that is how you are able to determine the strength of the chloride ions in the given water sample. And finally, you are going to quote the result which you have obtained. Now, the important note or the precaution is that, first of all, whenever we are performing this titration, we are not supposed to use tap water because the tap water may contain chloride ions. So what will happen if you are washing your flask, if you are washing your pipette, if you through the tap water, it may contain extra amount of chloride ions. Sometimes it happens as students, they wash their glasswares with the tap water and ultimately they are consuming more than 50 ml of silver nitrate. So that is why it is advised not to use the tap water, only use the distilled water which is provided to you. Number two, the given sample of the water, you need to test it for the acidity and alkalinity. So do it by using litmus paper. By the litmus paper, if it is slightly alkaline in nature, or neutralize it few drops of dilute nitric acid. If it is acidic in nature, you need to add ammonium hydroxide. And you can read the precautions. I already have explained that we need to conduct this experiment between the pH. It should be between the range of 7 to 8. Silver ions, they are precipitated as silver hydroxide at the high pH levels. And the chromate ions are converted to bichromates or dichromates at the low pH values. The volume of the indicator should be same in all the titrations. And before doing the blank titration, the pipette and the conical flask, it should be washed with the distilled water which is provided to you. So that is all about the explanation of the experiment. Now you are going to see the demonstration video. Thank you.